Now that we've seen the ins and outs of linked lists, it's time to tackle a couple of interview questions that you could really expect to see about them. So in this video, we're going to kick off our first question around linked lists, and we're also going to take a look at a problem-solving strategy for solving many different types of linked list questions. So the second half of this video, I'm going to show you a very strong problem-solving technique to use with linked lists. So if you start to skip any content in this video, please at least watch the second half so you can see that problem-solving strategy in action, because I'm going to give you a quick explanation of how it works in this video. All right, so inside my code editor, I'm going to find the Midpoint folder, and then I'll open up the index.js file inside of here. So this is the first question we're going to tackle. Notice that we're back to working with these functions like we were during the first half of the course. So we're not working with the linked list class anymore. We got through that thing. We're now going to go back to some function type questions. So this midpoint function is going to be called with a linked list. So a linked list will be provided as an argument to this midpoint function. The linked list that's going to be passed to this thing uses the same implementation as the one that we just put together a second ago. So inside the midpoint directory, you'll find the linked list.js file. And so here's the node implementation and the linked list implementation. They are identical to what we just put together. So just to be clear on that. So here's the directions of midpoint. Our goal is to return the middle node of the linked list. So the node at the very center of it. That might sound like it's really easy, but there are some requirements here. So specifically, we are not allowed to use any type of counter variable, and we are not allowed to retrieve the size of the list. So don't be thinking that you can call linkedList.size, get the total size, divide that by 2, and then retrieve the center element. That's not the goal here. The goal here is to somehow find the middle node of the linked list without knowing its size. All right, so we don't know the size. We have no idea what the size is. Don't try to access the size. Let's take a look at this question in diagram format just to make sure it's really clear. So we have 5 elements on the screen here for this linked list. So the center element or the midpoint or the middle element, whatever you want to call it, would be red. It's at the very center of the linked list. I think that's pretty clear. Now, one part that might be a little bit unclear is the second sentence of the directions. So if there are an even number of elements, we want to return the node at the end of the first half of the list. So in this example right here, there are 5 elements. So this is an odd numbered list. So the very middle element is really obvious. It's the one right here at the center. However, if we have an even number of elements, then things are a little bit more ambiguous. So here's 6. And at this point, there's really not necessarily a very clearly defined center node here, right? If we look at the very center, we're kind of right here in this gap. So what the directions are saying, the directions over here, what this end of the first half of the list is saying is take the first half of the list and then take the last node in that half. And that would be considered to be the middle element if the list has an even number of elements in it. So if there's an even number, essentially go to the middle, and then one less than that is supposed to be the midpoint. So hopefully that's clear as well. Okay, so that's kind of an overview of the question. We're now going to talk a little bit about the very general problem-solving strategy that we're going to apply to this problem and many other types of linked list related questions. So we're going to talk about this strategy now. This is a really important discussion because, again, you're going to be using this strategy in many different linked list questions. This can be used for a lot of different questions around linked lists. So let's get to it. All right, I'm going to pull up 2 little pieces of the diagram right here. All right. So let's walk through this. So here's how we're going to solve this particular question. We're going to talk about how we're going to solve the midpoint question, and then I think you're going to very quickly see how this strategy can be used on other problems. And we will take a look at some other problems that are going to use this strategy, so you'll have more than one opportunity to practice it. So here's what we're going to do. To find the center node, we are going to create 2 temporary variables. One is going to be called slow, and the other is going to be called fast. We are going to take both these variables and point them at the first node in our linked list. And when I say point at, I mean just we're going to assign the first node to both these variables right here. So essentially we'll say slow equals the first node, and fast equals the first node. That's all. After we do that initial assignment, we will then start to iterate through our linked list. So we're going to iterate through every node here. But here's the interesting part. For every step of iteration, like every step of a while loop, that's probably what we're going to use here. For every step of the while loop, we are going to advance this slow variable forward by one element. And then we will advance the fast variable right here forward by 2 elements or 2 nodes. So after the first step through the while loop, the 2 variables will be updated to look at these 2 specific nodes right here. So slow is very aptly named. We're always going to advance slow by 1 node at a time. But fast is going to be getting advanced by 2 nodes at a time. Now here's the real trick. As soon as we advance fast to the next node, we will then check to see if the node after the one that it's now pointing at is defined, and if the node after that is defined. So essentially, after we advance fast forward, we're going to check to see if the next 2 nodes exist. If they do exist, that means that everything's good and we need to still continue iterating through the list. But if either of these next ones do not exist, then that means fast must be at the end of the linked list, and that we could then consider slow to be at the midpoint. So let's continue this through and see how this really works in action. So at this point, we're going to say, okay, the fast node right here, does this have 2 nodes after it? Well, yes, and yes, they are. Okay, that's great. So we're now going to advance both of our pointers. Slow is going to move forward by 1 element, so it's now pointing at red, and fast is going to move forward by 2 elements, so 1, 2. Now we're going to ask the same question again. Look at the node that fast is pointing at, so purple right here. Are both the next and the element after that defined? In other words, are the next 2 nodes defined? Well, in this case, no, they are not defined. And so that means that we must be at the end of the list. So slow is now pointing at the midpoint because it's moving half as quickly as fast is. So as soon as fast sees the end, that means, okay, we're at the very end. Slow has been moving half as fast, so it must be at the midpoint. So that is the general problem-solving strategy that we're going to use for a lot of different questions. We're going to create these 2 separate variables, then we will iterate through our linked list. One will move forward at a slow pace of 1 node per loop, and the other will move forward at a faster pace of 2 elements per loop. And then we can make some comparison between the 2 of them and kind of derive some neat information about the linked list from that. Now, an immediate question you might have might be, well, what exactly happens if there's an even number of nodes in the loop? Like what exactly happens when there's an even number? I don't know. This is something that for me seemed a little bit mysterious. So just for completion's sake, I want to go through another iteration of this flow, but with an even number of nodes. And you'll see that whether there are an even or odd number, this strategy still always works out. So we're going to start off our loop again. Both slow and fast are going to point at green. We're now going to advance slow up by 1, and fast is going to move forward by 2. So 1, 2. Now we ask, does fast node have both elements in front of it defined? In this case, yes. So we're going to continue to iterate on. So slow is going to move forward 1, and fast moves forward 1, 2. Now we ask, are both 2 elements in front of fast defined? So we look at 1, yes it is, but then after that, nope, nothing else over here is defined. And that means that we must be at the end of the list, so slow must be pointing at the midpoint. And in this case, yep, it definitely is. Remember, we had said that if there is an even number of nodes, then we go to the midpoint, this kind of gap right here, and take the node right before it. So even if there is an even number of nodes here, we still end up getting the correct answer. Okay, so hopefully that makes a little bit of sense. I know that seeing it in diagram format and hearing it with words is really not the same as writing it out with code. So I encourage you to take a shot at the solution, and then we'll go through a solution to the real problem together in the next video. So quick break, give it your best shot, and we'll hook back up together in the next video. And one thing I forgot very quickly, don't forget to start your tests up with jest, midpoint, test.js --watch, like so. So don't forget to check your tests. All right, so take a shot and I'll see you in just a minute.